Welcome to MAT 109, Introduction to Statistics. My name is Professor Joseph C. Mason, and I will be your instructor for this course. We will begin in Chapter 1. In this chapter, we'll talk about terminology, definitions, and fundamental concepts for gathering data. Starting with some terminology and definitions. Statistics. This is the science of collecting, organizing, summarizing, and analyzing information to draw conclusions or answer questions. In addition, statistics is about providing a measure of confidence in any conclusions. Population. This is the entire group to be studied. Now, a population could be a small group of individuals or objects, or it could be a large group of individuals or objects. For example, we could take students in this class and call this in a population. This would be a very small population. Or we could talk about all students attending Hagerstown Community College. This would be a larger population. Or we could talk about all students attending a community college in the state of Maryland. This would even be a larger population. An individual is a person or object that is a member of the population being studied. A sample is a subset of the population being studied. For example, if we took the population to be all students attending community college in the state of Maryland, then all students attending Hagerstown Community College would be a sample of the population. Also, the number of the students in this class would be a sample of the population of all students attending community college in the state of Maryland. Parameter. A numerical measure of a population. We can find the mean, median, mode, variance, standard deviation of the population. We'll talk about these in later chapters. Okay, if we're talking about a population, we call these parameters. Now, if we're talking about a numerical measure of a sample, mean, median, mode, variance, standard deviation, now we're talking a statistic. So you're going to need to know whether your sample is from a population, whether you are dealing with a population or dealing with a sample. Now, there are two areas of study. Descriptive statistics. This consists of gathering data, organizing the data into tables and graphs, and finding numerical summaries. We'll talk about this in the first few chapters. Inferential statistics. This consists of taking a result from a sample, extending it to the population, and measuring the reliability of the results. We will do this in the later chapters of this course. Now, the process of statistics. First, you need to identify the research objective. So the researcher must determine the question or questions he or she wants answered and clearly identify the population is to be studied. Second, collect the data needed to answer the questions posed in number 1. Conducting research on an entire population is often difficult and expensive, so we typically look at a sample. This step is vital to the statistical process because if the data are not collected correctly, the conclusions drawn are meaningless. We'll talk about this in sections 1.2 through 1.6. Third, describe the data. Descriptive statistics allow the researcher to obtain an overview of the data and can help determine the type of statistical methods the researcher should use. We'll talk about this in chapters 2 through 4. And finally, perform the inference. Apply the appropriate techniques to extend the results obtained from the sample to a population and report the level of reliability of the results. We'll talk about this in chapters 9 through 15. Now, we have two types of variables here, qualitative and quantitative. A qualitative or categorical variable. This is a variable that allows classification of an individual based on some attribute or characteristic. Some examples would be color of eyes, color of hair, gender, make of car, phone number, zip code. Quantitative variable, on the other hand, is a variable that allows classification of an individual based on a numerical measure that can be added or subtracted to provide a meaningful result. Some examples here would be number of siblings, number of credit cards and wallet, temperature, miles driven, time to complete, height. Now we're going to talk about discrete and continuous variables. A discrete variable is a quantitative variable that has either a finite number of possible values or a countable number of possible values. The term countable means that the values result from counting, such as 0, 1, 2, 3, and so on. So the key fact here to remember is a discrete variable may only take on a whole number value. Some examples: number of siblings, number of credit cards and wallet, number of successes, number of keys on your keychain. If you think about this, these are all going to be a whole number value, 0, 1, 2, 3, etc. Now, continuous variable. This is a quantitative variable that has an infinite number of possible values that are not countable. Usually, in a continuous variable, you may include fractions or decimal values. Some examples would be temperature, miles driven, time to complete, height. In every case, you could have a fraction or a decimal in your answer. Now, levels of measurement. The lowest level of measurement is the nominal level. Okay? And the values of the variable are in name only, a label or a category. The values may not be arranged in a specific order or ranking. Some examples: color of hair. There's no order to color. Gender, male, female. Is there an order? Not necessarily. Make of car. Is it a Ford, Chevy, Toyota, Nissan? There's no order for the make of a car. Second, ordinal level. This is the next to the lowest level of measurement and has the properties of the nominal level of measurement. However, the naming scheme allows for the values of the variable to be arranged in a specific order or ranking. Some examples here would be letter grade received. You could get an A, a B, a C, or a D. Okay, there is a set order for letter grades. Shirt size: small, medium, large, extra large. There is a set order. Movie ratings: highest degree received, high school diploma, associate's degree, bachelor's degree. There's a set order, but again, they are in name only, but there is a set order. Interval level. This would be your next level. This is the next to the highest level of measurement. It has the properties of the ordinal level of measurement, and the difference in the values of the variable have meaning. In this case, we're going to use numerical values. However, no intrinsic starting point or zero exists. The value of 0 does not mean the absence of a quantity. Example: the year you were born. Does 0 mean that's where everybody starts? No, because we can have BC, AC, dates. Temperature. Okay, is 0 a temperature? Yes, but is it a starting point? No. Does it mean the absence of quantity? No. 0 is just another reading for temperature. Time of day measured in military time would be another example. And finally, the highest level is the ratio level. This is the highest level and has the properties of the interval level of measurement, and the difference in the values of the variable have meaning. But this time, there's an intrinsic starting point or 0 exists, and the value of 0 means the absence of quantity. Some examples here would be height. Do you see where 0 is a starting point, and it means the absence of quantity? Assessed value of a home. You know, if you had an assessed value of 0, what's that mean? That means absence of quantity, and it's a starting point for assessment. Weight of a candy bar would be another example. Okay, this brings us to the end of section 1.1.